This movie is on Learning Target number 4 in Unit 1, Geometry Measuring Angles. It's found in Section 1-4. Learning Target 4 says find and compare the measure of angles. So that's what we're going to do, find and compare the measure of angles. An angle is formed by two rays with the same endpoint. The rays are the sides of the angle. The endpoint is the vertex of the angle. So how can you name it? You can name it several ways. See here in blue, we can name it with the vertex A, point A. We could also name it as BAC, BAC, or CAB. Notice the three letters. The three letters help us to designate where the angle is. We could also put a number inside and call it by number, like angle 1. The sides of the angle are ray AB and ray AC. The vertex is A. Note that when you name an angle using 3 points, the vertex must go in the middle. In this example here, we have angle BCX, or we could call this angle XCB. Notice that C must go in the middle in both cases because C is the vertex. We also have the interior of the angle, and then we have the exterior of the angle. Pause the movie, answer these two questions, and press play when you are ready. What are the two other names for angle 2? So when we're looking at angle 2 right here in the middle, then we're going to be looking at angle DBC, or we can name it angle CBD. Notice that B is in the middle when we name that angle. What are two other names for angle DBA? D, and if I follow that, BA, that angle. Two other names would be angle 1, angle ABD. Do you think it's okay to put angle B? The answer is no, because angle B could be either angle 1 or angle 2. It's not as specific. One way to measure the size of an angle is in degrees. M means measure. So we write, look at the notation, the measure of angle 1 is 58 degrees. And we say that the little m stands for measure. So that's a little bit of notation that you will need to know and you will use the entire year. We have two postulates you're going to be adding to your purple sheet. The first one is a protractor postulate. It says to consider ray OB and a point A on the outside of OB. Every ray on the form OA can be paired 1-to-1 with a real number 0 to 180, meaning I could put a protractor on top of this angle and get a degree measure for the angle. That's called the protractor postulate. In 1/8, it says the angle addition postulate says that if I add two smaller angles, I will get the entire angle. And that's what our angle addition postulate says. Pause the movie, add these to your postulates sheet, and then press play when ready. The protractor postulate allows you to find the measure of an angle. The measure of angle COD is the absolute value of the difference of the real numbers paired with ray OC and ray OD. That is, if ray OC corresponds with C and ray OD corresponds with D, then the measure of angle COD is going to be the absolute value of the difference between the two. So C is located at about 135 and D here is located about 40. So if I find their difference, 135 minus 40, and then take the absolute value, I get 95 degrees. So the measure of COD is 95 degrees. That should look similar to when we dealt with the segments. You can classify angles according to their measures. Anything less than 90 is acute. If it is 90, it's right. Obtuse is between 90 and 180. And then a straight angle is equal to 180. Pause the movie, answer these 4 questions, then press play when you're ready. Okay, so the measure of angle TQU. If we look at TQU, we should get 60 degrees. With the protractor, you can go this way and do 0, 10, so you're going to use the top numbers. This is also an acute angle. Going to number 2, we've got UQV is 120 degrees, and it's obtuse. This is 90 degrees, and this is a right angle. And this is 45 degrees, and this is acute. So you can see how you did. Hopefully you did very well with the angles. Angles with the same measure are congruent angles. So this means that if the measure of angle A is equal to the measure of angle B, I want you to notice that the measures are equal, then angle A is congruent to angle B. The angles are congruent, but the measures are equal. That's something I want you to keep in mind. You can mark angles with arcs to show that they are congruent. Notice they each have one arc in them. So this has an arc here. Whoops. Undo. They each have a marking. We've got an arc there and an arc there. And that shows that they're both congruent. Angle DEF is a straight angle. What are the measure of DEC and CEF? Pause the movie, try this, press play when you are ready. If DEF is a straight angle, we know that they add up to be 180 degrees. So I know 11x, oops, I almost put plus, minus 12, that added to 2x plus 10 equals 180. So if I add my like terms, I get 13x minus 2 equals 180. Then I'm going to add 2 to both sides. 13x equals 182. And divide by 13. X is 14. X is 14, but that doesn't answer my question. What are the measure of DEC? DEC right here. I can do 11 times 14 minus 12. And I get that the measure of DEC is equal to 142. And CEF, I would do 2 times 14 plus 10. So the measure of angle CEF is 38. If the measure of angle ABC is 92, what is the measure of angle DEF? And if the measure of angle C is 41, what is the measure of F? Pause the movie, try this, and press play when you are ready. If we know ABC is 92, what is DEF? Well, I know DEF has the 2 markings just like B did. So this would also have to be 92 degrees since they each have 2 arcs. It tells me that they are congruent and their measures are equal. If the measure of angle C is 41, what is the measure of angle F? Well, F would also have to be 41 degrees. Because they each have 3 arcs to them, they are congruent angles and therefore their measures are equal. Pause the movie, try this one, and press play when you are ready. Oh, this is one we've already done actually. So this is the end to the angles.